Now, I know what y'all are thinking. Just how flat will I get pancaked by a powder coating oven? Hey guys, how goes? Martin here. I've always been intrigued about powder coating and adding that skill set. Once I started looking into it, I did a little research. There was no going back. I was tackling the building of this guy right here. This is how I did it. Here is the basic rundown for this oven build. It will have final interior dimensions of approximately 6 feet tall, 4 feet wide, 2 feet deep. It will as much as possible repurpose used materials to keep costs down, be efficient, safe, controllable, and compact, because I need to be able to wheel it through a hallway in the shop to store in the back room. I suggest a great site that has tons of info on powder coating and oven designs called powdercoatguide.com. They don't know who I am and I don't know them, but it provides pictures, instructions, the basic materials and tools required. I came up with a bunch of my own ideas, so this video will complement the information that can be found on that site. The design utilizes and repurposes a used commonly available conventional cooking oven, runs on the same conventional 220 volt power supply and plug, and includes an air recirculation system. If you're going to tackle something like this, really plan it out. It will save time. Here's my schematic. Construction is based on 2.5 inch by 1.5 inch metal studs. The top-down view on the left superimposes and merges the floor plan and the ceiling layers onto each other due to their similarities. Obviously, we don't need lights in our floor. The main door plan is on the right, which uses the donor oven door with its convenient glass as a peek door, which we can, well, peek through and do quick temperature readings without opening the entire main door and losing a ton of heat. I began by making the floor, but we are going to jump into the construction process on one of the walls because all the panels are made in a similar fashion and we're just changing the dimensions and the placements of the studs. The framing is done via a pneumatic riveting gun. I opted for 1/8 inch by 1/8 inch steel rivets because they were locally plentiful. I also grabbed some 1/8 inch by 3/16 inch for going through the odd section with multiple layers, like 4 layers of sheet metal. You can use 1/8 inch drill bits and wiggle the drill just a little bit as you finish the hole because the rivets will be too snug to slip in, or use a slightly larger bit like a 9/64 inch or a 5/32 inch. But if you go too large, the rivets won't grab, so test it out before drilling a bunch of holes. Mark out your placement of the studs, then start with the corners. Be precise with keeping your dimensions, but don't be too concerned yet about the squareness of the corners because the sheeting stage is what determines and maintains the squareness of each panel. If you are lucky enough to be using full, large galvanized sheets, you can probably use a few less studs, but I am placing my studs to line up with my overlap points on my narrower galvanized strips of sheet. Drill and rivet each hole one at a time in this phase of the framing because it's too easy to shift things out of position and you'll be wondering why your rivet won't go in. To sheet the interior of the oven, the guide suggests 16 gauge galvanized for the floor and 20 gauge everywhere else. I found lots of 18 gauge, so I'll be using it for everything on the interior. In my case, I reclaimed a bunch of old furnace ducting for almost nothing, and the only disadvantage to that is that, like I mentioned, it isn't 4x8 sheets, so I'll be making a bunch of cuts, laying down multiple swaths of overlapping strips, sealing the joints. With cutting discs and flap discs, don't skip the basic safety gear for your eyes, ears, mask up, because the dust is bad stuff. And be aware of where the sparks are going because you can start things on fire, including your clothing, dry grass, oil, gasoline. Now this is when you want to square things up with the first sheet. Start at the outside corners and double check for square before you drill and rivet the rest. And when you do not move anything. It's really easy to move it accidentally. See? The first strip was narrow, so before I throw on the next sheet, check square again. It might be possible to still tweak square a bit at this stage if needed. Note that I'm using the galvanized sheeting exclusively for the inner walls and surfaces of the oven because I have a different plan for my exterior oven skin. To seal up these sheeting joints, I had a couple of ideas. And first I thought I'd try some muffler weld. It's inexpensive and designed to cure well with heat cycles. The downside I found out right away. It's slow, it's messy, it takes some elbow grease to clean up, but it does work well. When I first started, it was consistently taking me about 22 seconds to drill and rivet a hole, but I was eventually able to get that down to about 15 seconds using the one at a time method. Once you are square and you've committed your panel with the ensuing rivets and your sheet cannot move, you can begin to drill multiple holes in one go and then rivet them all at once, and this goes much faster. The riveting may squeeze out your sealant a bit, so some continuing cleanup will be required. At this point, some onlookers may begin to get curious as to what you are up to. You get the idea with this basic panel construction. They are all made in a similar fashion. The sidewalls and back wall are then riveted together and onto the floor, and the fun, basic, easy structures of the oven are in place. Let's look now at the main oven door construction. This gets more complicated. The framing of the main door is going to be bilaterally symmetrical because we want to place the peak door near the top and in the center. An important measurement, the full width of the peak door needs to fit inside the main opening between these two studs, maybe a 1/4 inch to spare at each side. To plan for the framing of the peak door, we first need to claim the parts from the donor oven. Since we are using the donor oven door in entirety, we are also going to use its mounting surface, frame, and all functional hardware points, including the spring sections, so we need to free up all of that. Now that we know the exact size of the opening, we can place our studs to frame it. Again, drill and rivet a corner first, measure and rivet the internal studs, check measurements stay the same both sides, flip it over, and do the same to the other side. We are making the main door the entire front square area of the oven for several reasons. We want to be able to move or wheel in large or heavy items that may take up most of the internal area of the oven, and if necessary, be able to take advantage of kitty corner length, so we need full, easy access. It also makes it easier to hinge and seal. Downside is that it is going to be heavy, so we'll need to compensate for that. Here's the first sheet. Fit, drill, and rivet just the outside corners first, then check for square, make any minute adjustments necessary, then drill the next holes carefully without shifting anything, and rivet. Distract any complaints or chore requests you may receive with dance moves. It will likely elicit a response in kind. The subject is forgotten. It works every time. It's not a puma, but we're going to hide behind the camera just in case. Here's the next sheet. I keep the sheeting just a hair shorter than the frame size so that sharp edges aren't proud and can't snag or cut anything. Now to tackle the backer frame of the peak door. The lip of the donor frame needs to fit inside the sealed backer frame. In this case, the 2.5-inch studs will allow about 1/2 inch all around for the lip of the donor frame to easily slip inside. We are recessing the peak door into the main door as far as possible without losing any internal oven space, so need to create a solid and insulated thinner backer frame using metal stud with the stud track fitted over it, and using these in a flat position, which amount to about 1.5 inches of depth, against which we can mount the peak door section. There is cutting and fitting at every corner to allow interlapping joints. We start with the stud side and test fit it. It's nice and snug. Now we start with the first of the insulating and cut to fit insulation inside the stud section. We are using rock wool or mineral wool insulation that has several advantages over fiberglass, mainly being higher density, more compact, and ridiculous heat resistance. Cut and add the track layer of the frame, sealing the rock wool inside. Then we are riveting the daylights out of everything. Test fit again, and good to go. Now flip the door over because we want to position this backer frame flush with the inner galvanized side of the door, and it's easier to do with it all resting flat on the workspace table. Then position it and rivet it into the main door. Flip the main door over again and tackle the rest of the galvanized sheeting. By this time, I had changed my strategy with regards to sealing the overlapping sheet joints, and I'm using copper high-temp silicone sealant because it is much quicker to apply and easier to clean up. Drill and rivet all of that. On to the framing below. Get an upper track in place and fit the remaining studs. Cut, fit, seal, drill, and rivet the next sheet. As far as rivet placement, I'm eyeballing them and using a basic finger spread method to get quick, consistent rivet placement about 6 inches apart. And overlapping sheet sections only get riveted once, which makes for a tighter fit. So the holes are simultaneously drilled through 2 galvanized sheet layers and the stud in one shot, and riveted the same way. This also saves time and rivets. On to the other side, I'm leaving the center section for last, a bit easier to seal and more efficient for momentum perhaps. Last sheet in place. Let's now rivet in the donor oven door mount section right onto our metal stud backer frame, centered all the way around. I did add some short stud sections internally to add a bit more support where those legs extend down and where the springs bolt up. Here is what the peak door looks like mounted from the inside viewpoint. We need to allow the necessary clearance for the spring hardware to move through its full range, so made some long slits in the sheeting just big enough for clearance. Then bolt the peak door back onto its original mounting points, and we are functional. It seals perfectly. Now to insulate the main door with the mineral wool. The rock wool is easy to cut. This stuff is intended for 3.5-inch studs. We are squishing it just a bit to fit it, but it really works perfectly, as you will see. I'm saving all the cut pieces because there will be plenty of skinny nooks and crannies to fill, and this oven is going to eat up in the neighborhood of 100 or more square feet of it. A few custom insulation cuts are required around the peak door mount points and the springs. You know it, it's time for a drone flyover. Feast your eyes. You may notice that the white panel above the peak door is taken from the donor oven. I simply like the look of it. It was already the perfect width with rounded edges and everything. Next, we need to reinforce the right edge of the main door where it will be hinged. I'm using thicker galvanized 1.5-inch by 2.5-inch L angle right over that end stud, the full length of the door, and riveting it in place. The same will happen to the corresponding wall edge of the oven. This also provides more meat for the metal hinge screws to bite into. Okay, I want to show you guys a bit of old-fashioned metal shaping. I need to create a hot air duct that will be running down inside the back corner of the oven, taking the air from our fan in the ceiling and sending it out across the oven floor, creating our circulation loop. Okay, wow, I underestimated how loud that is. Earplugs, please. It needs to be Z-shaped because I don't have a fancy bender, only my custom long vise. I'll do it in a few sections. It works surprisingly well, better than you thought, I wager. Then, seal and rivet them together, add a nice perforated stainless grill at the bottom, and we are ready for install. And we are also ready to reveal the oven progress with the walls and the floor riveted together. Ta-da! The duct will run on the inside right down the back corner. I kept it on the inside for several reasons. I want that air to stay as hot as possible. I don't want to lose the insulation value if I were to put it inside the wall. It takes up very little space, and the lower half of it is behind the heating elements anyway. Okay, so today we're going to focus on installing our vent that's going to run up this back corner to the fan that'll be kitty corner, top of the oven up there. So that way we're going to get good constant convection and circulation happening. Okay, let's get sealing and riveting. A convection oven doesn't actually truly circulate the air. It basically just agitates it. And due to the difference in fan design, there is no need to look for a convection oven, since what we want is slow-moving air that is truly recirculating, because we want to try and maintain as even a heat from the top to the bottom of the oven as possible. Heat rises, so all our elements will be on the lower half of the oven, and our fan will suck up hot air along the ceiling and send it back out the bottom along the floor. Okay, next we're going to mount our first element. Get it a bit off the ground like that. This stuff bends really easily, so you can actually kind of bend it in the shape you want. So I'm going to just have this so that it slips in right about there. So I need a couple of holes. Drill through the back, and then I'll make an access plate in the back of the oven to be able to hook up wiring, ever change out the element if I need to, etc. Good. The two elements on the right side are installed in exactly the same way, and I confess, I must disappoint you now, there will not be a fifth element. And here's our first ceiling panel. There will be two on top of each other. It's where we need the most insulation. We also need extra space up there for some infrastructure. Our recirculation duct and fan blade section will be in the first layer, and our oven lights will actually pass through both these ceiling layers. I'll show you in a bit, and it'll all make sense. With the ceiling panels riveted into place, let's skip ahead a bit and I'll do some work on the floor underneath. You can see I've insulated and skinned my first wall. I'm using some nice reclaimed lightweight putty colored metal siding. It is perfect for this and should look sharp. Putting some insulation in between the studs on this end because I'm adding in some stiffer galvanized L-angle right over top as reinforcement for where the wheels will attach. I'm tapping the holes for the wheels because they are attached with actual bolts for longevity. The song Energy Czar just reached the chorus. Now we repeat the same thing on the other side of the floor for the wheels. I fabbed up a lift point for this oven since it will be getting too heavy to stand up and lay down by hand, however brute they may be. Now the irony is, in order to install this lift point, I will have to lift this oven up by hand one last time, which has to happen right now because everything I'm adding from this point will add significant weight, like the main door. Here goes nothing. Cue the sounds for the Bionic Man. I have it on blocks so it won't slide because the wheels can't touch. Whoa, it slid anyway. Okay, lift up without moving forward. Okay, good. Now hang on to the top for dear life so that it won't have momentum. Almost there. Touchdown. Okay, not so bad. I wasn't worried. Were you worried? Okay, let's rivet this lift point into place. I did the roof part already. Come on, can't we go any faster? That's better. Right, guess what? We have to lower the sucker again, but this should be easier. While I have this down, let's look at the ceiling recirculation vent duct made from two metal studs sealed together, indicated by the red arrows. That takes the air from our fan, which is just out of the picture top left, across the ceiling through a hole down to the wall duct that we installed inside earlier. Time to skin the floor. I can use a few less pretty pieces of siding here since this is the last time anybody will see them. How about a basketball career? Maybe next time. I'm riveting these skin pieces underneath because there's nothing here that needs any access. Anything requiring access gets self-tapping smooth, flush sheet metal screws. We are getting close to installing our main door. It's time for the main door seal. I got a bit chintzy when I ordered this stuff. I only got 20 feet of it, but I lucked out because they sent me a bonus couple of feet. And we can move our main door into place. It was awkward. I used a dolly. I knocked the camera off the wall, but it's there. I think it's a good idea to finish the skin of the main door while the door is lying perfectly in place on its seal so that the door will be shaped exactly to fit. The skin layer adds a lot of rigidity. Wait, hold that thought. Energy Czar just came on again. Anyways, as I was saying, the skin layer adds a lot of rigidity, and we don't want to install the skin with even the slightest bit of twist due to gravity. Right now, the seal is perfect, and we want to hinge it in this exact position as well. This piece that wraps around the peak door needs some custom cuts. Also need to leave a bit of room underneath for clearance as the peak door swings open, and then think of something flexible to install there to take up the gap. Just a couple more custom pieces on either side of the door, and we are ready for the hinges. Okay, it's time for another smooth panoramic drone flyover. Whoa. The hinges are installed. Do you think I have enough of them? For a door of this weight, the more attachment points there are, the stronger both the door and the oven wall to where it attaches become. You may also have noticed how I am trimming out my edges in white metal flashing. If you are really good, you will have figured out what I'm going to lift the oven with. The boxing bag retreats up into the ceiling. There's a winch in the attic. Sometime I'll show you guys just how bad my winch addiction actually is. Tipping point. Ready or not, here we go! Yes! Needless to say, reports of my death via pancaking were highly exaggerated. Just where do you think you are going? So, immediately, I made a decision that will help this heavy door situation. It gets its own identical swiveling caster wheel. Finishing up the insulation on the left side, we're going to mount our oven control center right over top of it. I fashioned this fancy box out of stainless commandeered from an old barbecue. and with some TIG welding and bolts that are welded through the inside, it can be nutted onto the stud framework from my control section, which you can see there. It serves as a solid and, more importantly, stylish latch point into which to send a sliding lock bolt from the door, which doesn't protrude any more than the peak door. Yes, they get the idea. And there it is, deliberately drilled the hole in a manner to make it a tight squeeze. Now we need 2 more sliding lock points just like this, less fancy though, to hold the door firmly in place. The heat is really going to try and twist it. I jacked it up to give me some tool clearance for the bottom one, and then the same thing for the top of the door. All done. Let's look at the electrical wiring. The original stuff is not nearly long enough. I ordered 50 feet of high temp stove cord, and that was barely enough. Anytime it needs to pass through a stud or any metal hole, I sleeve it with these short sections of thick silicone coolant hose. We are looking at the back of the oven, where the cord runs to the prongs of my 4 bake elements and to my temp sensor. Let's go up on top of the oven and examine what I did for my fan setup. I rescued an Electrohome fan from a wood stove for $5. It will move around 80 to 100 CFM, which should be perfect. Very similar to the one pictured here. What a beauty! Look at that snail! But it isn't intended to be constantly moving 400 to 500 degree air, and the motor is supposed to be situated with access to ambient air, so I did this custom setup. The aluminum exhaust looking thing actually draws colder air that isn't being radiated from the top of the oven. Don't mind the dirty welding with the sea salty aluminum. Essentially, I separated the motor section from the blade section and added a 5-inch shaft in between. This allows me to mount the motor entirely in ambient air outside the oven, and since the motor is usually dependent on its own blades for cooling, I added a computer fan right on top. The whole unit is mounted on 2 vibration dampener points, one here, and the other right here. They are just slices of thick coolant hose. And it can be angled with this wing nut to center the fan blade section in its new housing with little clearance to spare. Yes, there are less complicated ways to do this, especially like just forking it out for high temperature fans. But this way will maximize longevity for this motor, keep all the heat inside the oven, and move the hot air we want. Here's the blade section in the oven ceiling. Let me also point out the temp sensor location, the very far back corner, top right of the oven, top center left in this frame. $5, just remember that. The boxes for the lights are ordinary electrical light boxes, mounted inside some galvanized tubing with ceramic fixtures. The area above the lights will get an additional extra thick insulation layer, and I added an electrical outlet to supply my 2 fans. This outlet will get its own switch in the control section. So as you can see, no need to be fancy up here. An oven, when you take it apart, is frighteningly simple. You will actually wonder what on earth costs so much. I mentioned earlier that this oven will have 4 bake elements, because in addition to the bake and broil elements, we are commandeering 2 of the stove plate element controls. Now most stoves will have high output plates and lower output plates, indicated by the wattage as seen here. We want to utilize the ones that say along the lines of 2100 watts to 2600 watts. We are using 4 generic 3000 watt short prong bake elements that were the right size and shape. The 2600 watt pots will heat them up no problem. I removed the 2 lower wattage pots and mounted my fan switch in its place. The wiring runs from those pots to the control section, and from the 220 volt power supply up to the control section. I commandeered this rear panel from the donor oven because it looks kinda cool and hides some wiring, but there is literally not much going on in the back of an oven. I'll show you if you insist. Are you listening to me? You seem to be distracted by one of the oldest items in my clothing line. It's a kokanee toque that came with a case of beer about 20 years ago. Unplug your oven before you touch anything back here. Panel off. I told you there was nothing back here. Incoming red is hot, so is the black on the other side, the white common is up the middle, and the green ground is far right. You can get 120 volts by running from either the red or the black, and with the common and ground, which I did up to my switch and then to the electrical outlet. That's about all there is to it. The skin on the back of the oven is done with self-tapping screws, so they can easily be removed to give me access. Anywhere we may want access, we don't rivet. Add the trim and we are so close to done. Here's the added insulation box above the lights. The top of the oven is finished. I added a door sweep upside down underneath the peak door to close the gap in a flexible manner. Let's have a look inside and see what still needs to be finished there. I want to add some galvanized heat shields, it's just galvanized siding, to disperse the direct heat so that if I have large items in the oven that are in close proximity to the elements, that they don't get localized overcooking. I cut a number of slits. I may want to add even more for breathability. Ideally, we want about 150 watts per cubic foot of oven space, so around 7,300 watts for this oven size.
We have a total of 9,200 watts flowing to our elements. Unless we engage the broil directly, it only supplements the preheating. And they aren't even being used to their max of 12,000 watt combined, so we should be in fine shape. Our power draw will be max about 38 amps. Perfect. I think we are ready for testing. Time for some 3D flybys. It's time to buzz the tower. Whoa! A useful addition, especially if you will want to move the oven around, is a good long 220 volt extension cable, capable of 50 amps over its length, containing, I suggest, 6-gauge flexible copper wiring.
Okay, I'm running the first full heat cycle on this thing. The fans are going. The elements are going. The lights doing their job. See, there's definitely some smoking now, as we're going to burn off everything on the surface of all the metal. Basically start the cycle when it hits 400 degrees in there. We'll find out. I'm also curious to see what kind of heat is going to come out around this fan area, because the shaft still, it's tight around the shaft, but there still is a way for heat to come up there. So far so good. There's definitely heat coming off it, but it's not nothing major. Really also not feeling heat on the top of the oven at all. It's lukewarm in a few places. That's it. And above the lights, nothing. Still cold actually to the touch. You can definitely see the effect of the fan. The smoke is definitely moving around nicely. That is as much air circulation as I would want to see inside this oven. You can actually see the pattern of the air movement. You guys probably can't pick that up on the camera, but I can really see the air movement coming up and then across the top towards the fan over here. And holy, yeah, it's definitely heat in there. I'm gonna grab my infrared temp taker, and we're gonna just check the temperature of the walls. That'll give us an indication of what's going on.
So the testing was a success. Preheat time for the oven is about 20 minutes. I think my heat shields inside can be a bit more sparse and block just the direct element heat, so I cut the center sections out. We want the heat to come into the oven as much as possible and not get sent back into the wall. I also slipped in an additional stainless layer in behind the elements to provide additional protection from that direct element heat, especially with the seam there. It can't hurt. I also made a shelf to sit a few items on, obviously items that aren't getting powder coated on the bottom. It'll be one of many little tools, no doubt, to make it easier to bake items. A full-size rack on wheels is imminent. Okay, I gotta bake something. Give me something to bake! Powder coating gear is ordered and on the way. I think I'm going to tackle my own sandblast setup. That is next. Stay tuned. This is all going to come together pretty quick now that the big job is out of the way. Check out these new recent videos wherever they are. One is about Gandalf, the world's first 5S GTE Mark I MR2. The other is about the building of this whole garage shop. Thanks for watching. Ciao for now.